I never thought I'd say this, but astronomers have almost certainly, with near 100% probability, finally discovered life on another planet. When did this happen? In April 2025, National Aeronautics and Space Administration received undeniable proof of life on the object K2-18b. And this is a real sensation not only in the scientific world, but also in society. Don't you believe that there is life somewhere besides Earth? Considering that astronomers haven't solved even a tenth of the mysteries of the macrocosm, rejecting the possible existence of extraterrestrial biosignatures is like stubbornly pushing a cart when humanity has long since mastered rockets. So, on which exoplanets have recent studies found evidence of life, and what might extraterrestrial biodiversity look like? The reality is that modern telescopes are literally spamming us with creepy details about discovered exoplanets. They scare us with super Saturns, with monstrous rings that can cause stellar eclipses. They claim that somewhere there's a planet spinning around that's a giant diamond boulder, and they release information about a celestial body that's gradually evaporating. Of course, with news like this, an ordinary person naturally wonders, can life really develop in such conditions? Paradoxically, in some places, there might even be indirect evidence for this. So before presenting the guaranteed candidates for the discovery of biosignatures, let's take a quick tour of extreme objects. Look out the window. Is it raining? It's good that you're on Earth right now, because on the exoplanet wide-angle search for planets, 76b, due to the extreme temperature differences and mega hurricane winds, the rain isn't made of water at all, but of molten, scorching iron. This ultra-hot Jupiter, where a year lasts less than 2 days, is located 140 light-years from Earth and is remarkable for its incredible surface temperatures. Daytime temperatures reach 2,400 degrees Celsius, dropping to 1,400 at night. Is there any evidence that it floats? Does the planet really have iron rain? Yes, in 2020, the VTL Observatory provided such evidence by detecting neutral iron in the atmosphere. The temperature amplitude mentioned is exactly what's needed for this element to evaporate and condense. So if you're on wide-angle search for planets, 76b, it's better not to leave your house on a rainy day. The main question is, can life exist in this hellish place? Did you hear that? Something just fell. That was the needle on the probability scale. Indeed, the probability of life existing on this gas giant is low, but thermophiles, silicon-based organisms resistant to metals, could still be found in the planet's clouds. The main thing is to get there and check. The more videos about space I make, the more convinced I am that God does play dice after all, and the universe loves to surprise us. Can you imagine what was happening on the surface of the planet Kepler-70b when its star turned into a red giant and burned the celestial body down to its rocky core? This is a likely scenario Earth will face in 5 billion years. Here's a cosmic spoiler for you. Kepler-70b, a former gas giant located 3,600 light-years away from us, which gradually turned into a rocky body smaller than Earth. The star in Kepler-70b's sky takes up about 35% of the sky because the distance to it is less than that from Mercury to the Sun. The temperature on its surface is about 6,700 degrees, which is higher than on the Sun, and the planet itself is evaporating. What about life on this celestial body? Probability scale remains at the bottom of Dobila. The molten surface destroys any molecules, although some astrobiologists talk about possible plasma life in the lava oceans. But are there any among the cosmic entities? There is almost certainly life. Meet her. The first contender is the exoplanet K2-18b, which we mentioned at the beginning. It was discovered by the Kepler telescope in 2015. The planet is located 124 light-years away from Earth. Most likely it is tidally locked, which means that one hemisphere is always night and the other is always day. The first telescope to detect water vapor in the atmosphere of K2-18b was Hubble, and this was an unprecedented discovery on a planet located in the habitable zone. Then, in 2023, James Webb detected carbon monoxide, 2 and CH4, that is, carbon dioxide and methane, in the spectrum of the celestial body's atmosphere, which may indicate the presence of oceans. And in April 2025, something incredible happened. A team of scientists from Cambridge University, after carefully studying the spectral analysis presented by James Webb, discovered dimethyl sulfite and dimethyl disulfite. These gases on Earth are produced exclusively by living organisms, for example, phytoplankton. And most importantly, these substances break down very quickly, which means that if a huge concentration is detected, their amount is constantly being replenished. Don't you think the universe is trying to tell us something? There is a high probability that K2-18b is an ocean planet with a hydrogen atmosphere, home to primitive microbes. We can't really talk about complex life due to the lack of land, but that's not certain. It's possible that organisms, having adapted to the colossal pressure of an ocean up to 15 miles deep, have evolved into amorphous jellyfish, completely blind glowing whales, or exotic sea snails. I wonder what kind of signal these mysterious creatures would send us if they were intelligent. We have transformed the oceanic soundscape, and listen to how this signal would sound. Who is the second candidate for the discovery of life? This is the Earth-like planet, transiting exoplanet survey satellite object of interest, 700D. The object is located in the constellation with the romantic name Dorado, at a distance of just over 101 light-years from the Sun. The planet was discovered in 2020 by the Transiting Exoplanet Survey Satellite Space Telescope, using the transit method. Interestingly, Transiting Exoplanet Survey Satellite Object of Interest, 700 DI's parameters, closely match Earth's, and it is in its star's habitable zone. This is indicated by the D index, from which it receives about 86% of the light, based on a comparison between Earth and the Sun. The planets are among the top objects discovered by this telescope because they have a coefficient of 0.84 on the Earth Similarity Index scale. Further research confirms the probability of the presence of liquid water in the atmosphere, and therefore habitability. 70%. Who could live on this planet? Possibly microbial life in the oceans like cyanobacteria or archaea, and if there's an atmosphere, alien forms of life, multicellular ones like Earth sponges. And finally, do you want to meet the most likely candidates for the pedestal of habitable planets? 3 objects share it: KOI 913102, KOI 48781, and TIGARDENB. Let's start with the last one. This planet, located in the habitable zone of the red dwarf Tegarden, which dimly shines in the constellation Aries, is 12.5 light-years away from our star system. It has the highest Earth Similarity Index, and the approximate surface temperature is about 28 degrees Celsius. That means it's quite possible that there is liquid water on this exoplanet. Accordingly, there is a high chance for the emergence of complex organic matter. The features that argue against such a scenario are the strong tidal locking with the star, which causes temperature variations from extreme cold to suffocating heat, conditions that living organisms are unlikely to adapt to, except for a tiny transitional zone that barely balances on the edge. Therefore, if there is life on the planet, it is most likely in the form of extremophiles in the ocean, on the surface, or in the atmosphere. It could also be radio-resistant bacteria, which are also found on Earth. KOI 4878-1 is the second exoplanet that shares the podium in terms of habitability. You might be surprised by the SE coefficient of this celestial body, but it's almost 98%. That means the planet is very similar to Earth. Of course, that doesn't automatically make it habitable. For example, Mercury, Venus, and Mars also score high on this scale, but as we know, that's absolutely dead worlds. It's more logical to search for life on such planets than in the branches of hell mentioned earlier. Here, the probability that the conditions for the formation of biosignatures will be suitable is much higher. So KOI 4878-1, located 1,120 light-years away from us, orbits a star, a solar analog. The equilibrium temperature on the planet is about 15 degrees Celsius, which is suitable for the presence of liquid water and an atmosphere. The object is located within the Goldilocks zone, that is the habitable zone, and receives as much energy from its star as Earth does. In 2024, an article was published in a scientific journal proving the attractiveness of this object for the Search for Extraterrestrial Intelligence project. In 2026, the Plato telescope is scheduled to be launched, which should lift the veil of mystery surrounding this planet and determine whether there is actually life on it. But what is the ideal twin of Earth? An exoplanet candidate with a record SE coefficient? This is KOI 913102, an object located just 42 light-years from Earth in the constellation Vulpecula, near a star similar to the Sun. It's a perfect target for James Webb's research, first because of the object's relative proximity, and second, because of its characteristics. An almost exact copy of Earth is located in the habitable zone, receives the same amount of light from its star, and most likely has an atmosphere containing water and oxygen. That means there could be oceans and continents on the surface, as well as a similar climate. And this is an intellectual sensation because according to computer models, the chance of life arising on this celestial body is at least 80%. But who is trailing at the rear of the list of habitable planets? Are such objects really hopeless? And is no one able to survive on them? Judge for yourself. Kepler 1649c, located 300 light-years from Earth and orbiting a dim red dwarf in the constellation Cygnus, it resembles our planet. But the behavior of its parent star is unlikely to allow any life to develop on the object. Why? Because frequent flares from the red dwarf regularly sterilize the surface of the planet, which is within a dangerous radius. Hypothetically, there could be organisms here that are adapted to such flares, as well as neurobes or microorganisms whose photosynthesis operates in the infrared range. That is, they use not visible but infrared photons. Astrobiologists have been discussing the existence of such life forms for years in the context of possible biosignatures on planets orbiting red dwarfs, although this has not been experimentally proven in any way. Do you know how the expression "neither fish nor meat" is interpreted through the lens of deep space? The embodiment of this saying is J1407b. After all, scientists still can't figure out what it is. A gas giant, a brown dwarf, or even a substellar object. It is known not only for this feature, but even more so for its incredibly large rings, which have a radius of about 100 times that of Jupiter. For comparison, the radius of the largest ring of this planet is 90 million kilometers compared to 480,000. kilometers for Saturn. If our gas giant had such rings, they would dominate the Earth's sky. The object is not bound to any star and is most likely a rogue, forever traveling through the universe. Earth-based telescopes discovered it by accident when it was passing by one of the stars. And this gives a unique opportunity to study the object and draw conclusions about its habitability. And this is extremely unlikely. First of all, most of its existence is a lonely journey in the darkness and freezing cold of space. Secondly, J1407b doesn't have a solid surface. Thirdly, due to its significant mass, the celestial body has extremely high gravity. So who could live here? If there's methane or ammonia in some layer of the planet's atmosphere, then extremophiles similar to our tardigrades on steroids could be crawling around in those clouds. And even that is unlikely without the energy of a star. What do you think? Is it possible to survive on a planet that's evaporating like Kepler 70b, or to exist there comfortably? Across the whole sky, if it were possible, it would go across the whole sky. If across the sky, if it were possible, it would go across the whole sky. About golfer species, who said lethal doses of radiation instantly destroy all living things. It's like settling inside an ultra-dense nuclear reactor. Congratulations, we've reached the planet with the lowest habitability rating. After all, the probability that there is any life on PRS J1 7191438b is 0. Finally, I'd like to ask, do you believe in intelligent or any kind of life on other planets? If not, then why? Write in the comments. If yes, share what you think it's like.